Hi everybody, and welcome to the last video on vectors. In the next video we will turn our attention to arrays. So this is the last video on vectors that we will have. And in this video what I want to do is put the concept of vector together with all of our previous concepts. So I want to write a program that incorporates vectors with loops, with if statements, with basically everything we've done. So to do that, what we're going to do in this video is write a program that plays a game called Nim. So vectors will be used heavily in this program, and you can see how they interact with loops and if statements and whatever else we're going to do. So basically we're just going to use this program, and this is a game whose rules I will explain, but we're going to write a game program, and the actual game doesn't matter. I just want to do a program that unifies a bunch of stuff that we have done. So that's what we're going to do. So before we write a program that plays this game called Nim, I assume most of you don't know how to play this, so let me explain the rules to you. You start with several piles of rocks. The number of piles is arbitrary. You can have 30, you can have 2 million, it doesn't matter. On your turn, you choose a pile, and then from that pile, you take as many rocks as you want. That's all. So this is a two-player game. On your turn, you choose a pile, take some rocks away. On the next player's turn, on player 2's turn, he or she chooses a pile, takes some rocks away, and then it's back to you. And this keeps going until somebody takes away the last rock. Whoever does that wins. So just for example here, suppose you only have 2 piles and one has 5 rocks and one has 7 rocks. On your turn, you start by choosing a pile. So you can choose the first pile or the second pile. If you choose pile 1, you can take as many rocks from that pile as you want to. So you can take 1, 2, 3, 4, or 5 rocks. If you choose pile 2, you can take up to 7 rocks away from that pile. And that's it. Once your turn is over, it moves on to the second player's turn, and then he or she does the same thing. And then it's back to you, right? Just back and forth. So for example, if you want to start analyzing how to play this game, suppose I'm player 1, I choose pile 1, and I remove all 5 rocks from pile 1. So and I'm allowed to do that, right? So I choose pile 1, I take all of the rocks away. If you are player 2, what should you now do? Hopefully it's clear what you should do. The person who takes the last rock wins. So if there's only one pile left and you want to take the last rock, you should now just move on to pile 2 and take all 7 of them, and you will win. Okay, so that gives you a little bit of a flavor of how this game goes. Okay, so we're going to write a program that lets the user decide how many piles of rocks there are, how many rocks are in each pile. And we're not going to program this to have 2 people play. We will have player 1 be a human, be a user, and player 2 be the computer. And this is only going to be a 30-minute or less video, so we're not going to worry about having the computer play in a hard mode. So the computer will just choose things at random. It will choose a pile at random and choose a number of rocks to take at random. Okay, so with these rules in place, this is the kind of program we're going to write. Okay, so now let's go to our compiler, and I'm just going to write this program from scratch. I haven't written it yet, so you will just see me writing stream of consciousness-ish. One thing I want to point out, though, is that the program we are going to write is fairly sophisticated, and I hope by now you have realized that programming is a creative activity. One thing you may want to do before you watch me write a program is think through how you would write a program that plays this, that does all this, right? That lets a user play with the computer until all of the rocks are gone. The program that you write on your own, without any influence from me, will most likely be much different from what I am going to write. Okay, so anytime you want to write a program that does something sophisticated, there are usually dozens, if not hundreds of ways to write a program that does that. So I'm going to write a program that occurs to me, but a different program might occur to you that will do the same thing. Okay, so at the very least, just sort of stream of consciousness like here, the first thing I want to know from the user is how many rock piles are there? You know, how many piles do you want to play with, and get that from them. So now we know that there are n piles. And then it seems to me the most natural thing to do is each pile has an integer height, so let's keep track of all of the piles and all of the rocks inside the piles with a vector. So each entry in this vector contains the number of rocks in the given pile. Okay, so what that means is like if you access piles bracket 0, you're looking at the first pile, and this exact number right here will be the number of rocks inside that pile. Okay, so we're just keeping track of the pile heights with a list. That's all I'm saying. A list of length n. Okay, so let's now let the user tell us how many rocks are in each pile. So if you ever want to give values to a vector whose size you don't know, the best thing to do is just use a for loop and go entry by entry. And let's just ask the user how many rocks are in pile, and then we're going to do this one at a time. So how many rocks are in pile I? So as I keeps tracking, right? So we're going to ask about pile 0, pile 1, pile 2, etc. And since we're going to make this program user-friendly, let's just warn them. You can think about how to make your program let the user start counting at 1, so have pile 1 instead of pile 0. But again, this is a short video, so let's not worry about doing that for the user. Let's just tell them, hey, look, I'm counting from 0 to n-1, whereas you are probably counting from 1 to n. Right, so let's not worry about making that easy for them. And so now let's just get the number of rocks in the given pile. Right, so this counter I is keeping track of which pile you're looking at right now. And if you're actually writing this program for real, you would want all sorts of checks on what the user does. So I'm not going to add all of the ones you would want, but here's something you might want. Suppose the user right here enters a negative number or the number 0. You don't want that, right? You don't want a negative height pile. You also don't want an empty pile at the beginning. I mean, there's nothing necessarily wrong with an empty pile, but the user should have just not included that pile in the count. So let's just tell them this. If they enter something negative, pile size must be positive. And then let's make them do it again. Okay. So what this, oops, why did I double type? There we go. Okay, so this global for loop here is going to get the heights of the piles, right? We're going to go pile 0, get the height, pile 1, get the height, pile 2, get the height, all the way up to pile n-1 for a total of n piles. And at any point in this process, if the user enters a negative number or a height 0 for the pile size, we're going to force them to try again. So as of right now in this program, we have set up the initial game board, right? We have all the piles and we have all of the heights. And so now let's just tell the user, okay, here is the starting configuration, and let's print the vector that we have now. So this loop I'm going to write right here is always the loop you will use to print out the entries of a vector. So let's see out the entry at position I, and well, let's separate them with a space. And then once we're done printing, we'll put a new line in. Okay, so before we move on, let's just check that this does what we think it does. So before we, so let's say there are 3 piles. How many rocks are in the first pile, which is pile 0, right? Let's say that there's 2 in that, and then 4 in pile 1 and 3 in pile 2. So it says, here's the starting configuration. There are 2 rocks in the first pile, 4 rocks in the second pile, and 3 rocks in the third pile. Okay, so it does what we want. And let me just fix some of this formatting here. Okay. So once we have the game set up, right, we have the piles, now we need to actually play the game. So we need to allow the user to choose a pile and remove a certain number of rocks from that pile. And we have to let the computer do it on its turn. So now we have to set all of that up. So there are many different ways you can do that, but it seems to me that what we should do is keep track of just how many stones there are in total. So in this output right here, right, there are 2 here, 4 here, and 3 there. That means that you're starting with 9 stones. int total stones, yeah, is initially 0. So what we're going to do is we're going to figure out how many total stones there are. So what I want is a for loop that would just start at position 0, go all the way up to n, and what we're going to do is just get the number of rocks in each pile. Oops. Plus. Okay, so what we've done here is we started with total stones being 0, and then we just went pile by pile and added the number of rocks in a given pile to that. So just to check that that did what we want. Total stones. Let's just check that this works. Okay, so how many piles are there? Let's do 3 again. 2, 5, and 7, maybe, right? So that's a total of 14 stones. So notice here at the bottom it says 14 because it's printing out the total stones. So this does what we want. This for loop will tell us the initial amount of stones. Okay, so basically now what we want is we want a loop that will let us keep playing the game as long as there are stones on the board. Right? As long as there are still rocks there, we want to keep playing. So the gameplay itself is going to go inside a do while loop where we want to keep playing as long as the total amount of stones is positive. So as long as there are still rocks on the board, you want to be able to keep playing. But as soon as there are no more rocks on the board, you want to stop playing. And of course you also want to be able to tell who won, you know, whether the human wins or the computer wins, you should be able to tell. But anyways, that's all going to go inside this loop here. We're going to play the game, right? Play game, right? That's all going to go inside this loop. We're going to keep playing until all of the piles are empty, at which time the amount of stones is 0. Okay. So now, let's just think through the logic of what should happen. You're player 1, you're the human, so, and again, you could think about letting the computer go first and you go second, but we're not going to add that layer onto this particular game. So let's tell the user, choose a pile. And let's again warn them, keeping in mind that the piles are labeled 0 through n-1, right? So if you don't remind them of this, it's easy to forget. And let's close that parenthesis. Well, if we want them to choose a pile, we actually need a variable to keep track of that. So right above my loop, let me declare a variable called pile, and let's get that from the user. Maybe let's call it like pile choice, just so it becomes clearer. So this is what the user has chosen as their pile. So then you say, okay, once you've chosen a pile, how many rocks do you want to remove? And for that, we also need a variable, right? So let me just, number of rocks, or whatever you want to call it. So how many rocks do you want to remove? Well, let's get that from the user. Okay. Now, though, again, you should, if you were writing this for real, you would have all sorts of checks. So let me just add a check right here. While that number is less than or equal to 0, and also if that number is, so this is like if the number is too small, right? You can't choose 0, you can't choose negative numbers. It doesn't make sense. But you also don't want to let the user choose a number that's too big. So basically here, as long as the number is too small or too big, but what does too big mean? It means that you've chosen more rocks than are in that pile. Okay, so again, this condition is saying that the number they entered is nonsensical because they entered a negative number or 0. This condition is saying that they chose a number that was actually more than the number of rocks in that pile, and that's not allowed. Right? If your pile has height 4 and they choose 7, you can't do that. You should force them to give another number. So we can just say something like, you can't enter a non-negative, you can't enter a non-positive number, and you must choose a number that is less than or equal to the number of rocks in this pile. Whatever. And then make them go again. Okay, so here we've made them choose a pile, and again, we could add more checks. Like right here, we could force them to not enter a negative number or a number that's too big there. But again, if you were writing this for real, you would have these checks all over the place. But let me just throw a few of them in so you can see what they would look like. So you get their pile choice from them. I want pile 2, I want pile 3, whatever. Then you would get the number of rocks you want them to remove from that pile. And so once you have that, let me just make sure that when I output this in the end, things are on new lines. Once you have that, what you should do is make sure that you take the current pile that they've chosen and you reduce the number of rocks by what they've chosen, right? So this is the old value of the height at that given place. This is the choice of pile, right? So pile 1, pile 2, whatever. And this right here is the number of rocks in that pile. So what you want to do is take the number of rocks from the pile they chose and take out the number of rocks they chose. So suppose that this number is 8, right? There are 8 rocks in the pile they chose. If they chose a 3 right here, you should take those 3 rocks off that pile and create a new pile size. Okay, so let me just walk through that again. This right here represents the number of rocks at this pile choice, right? At pile 3 or pile 4, whatever. You take the number of rocks in the given pile, take out the number that the user chose, and now that's your new height at the given pile. You also, since you're keeping track of the total number of stones, you want to make sure you that you take out what they chose from that also. Right, so this right here is saying, okay, at the given pile, take away the number of rocks they chose. And this is saying, well, we're keeping a running total of just the rocks on the board. So if the user takes away this many rocks, number of rocks from a given pile, that many rocks disappears from the board. So we're going to keep track of that in our total stones variable. Okay, so you've done it. You have taken care of a user turn. You let the user choose a pile, you let the user take a certain number of rocks away from that pile, and you recorded that that happened. So let's just say something now like, okay, here is the game board now, and let's just now tell the user what it looks like. So, oops. So like always, we're just going to use a for loop to print the game board to the screen. So piles. Okay, so again, this for loop is just going through the piles vector. And again, piles is the list of pile heights, right? It's the list of the number of rocks in a given pile. And you're just going to go entry by entry and print the number of rocks in each pile to the screen, one at a time. That's what's happening here. Okay, so now it's the computer's turn, right? You took a turn, you chose a pile, right here, you chose a pile, you took a certain number of rocks away from that pile. Now it's time for the computer to go. However, if you've won already, right, which isn't likely, but on certain different pass-throughs through the loop, right, maybe you've won after your turn. So if the amount of stones reaches 0, then you want to say, you know, good job, right, you won this. So if after your turn is over, the number of rocks on the board is 0, that means you won because you took the last stone. Otherwise, it's now the computer's turn, and let's just give different names to, because the computer has to choose a pile, right? The computer also has to choose a number of rocks to remove from that pile. So let's give names to both of those. Right, so you made a choice, right? And you took away a certain number of rocks from that pile. The computer has to do the same thing. The computer is going to choose a pile. The computer is going to choose a certain number of rocks to remove from that pile. But this is easy mode, so the computer is not going to put any thought into this. The computer is going to choose a pile at random. So this code right here says choose a random number between 0 and n-1. And that is how we've labeled the piles, right? The piles go from 0th pile to n-1st pile. So the computer is going to make a choice randomly. It's going to choose a pile at random. However, the thing is, at the beginning of the game, all of the piles have rocks in them, right? Every pile has a height. However, as the game keeps going, some of the piles will become empty once you've taken the last rock from individual piles. And so you don't want the computer to randomly choose an empty pile, right? You want the computer to choose a non-empty pile so it can take something from it. So let's just force that to happen. So what this line of code is going to say is, as long as the number of rocks in the pile that the computer chose is 0, you should make the computer choose again at random. Okay, so again, this line of code says, computer, choose a pile at random. However, if that pile is empty at the current stage of the game, you don't want the computer to choose an empty pile. That pile is gone. So what you say is, okay, as long as what the computer is choosing is empty, so it has no rocks in it, you should force the computer to choose again. So when this loop exits, that means that the computer has finally chosen a non-empty pile. And so now that it's chosen a non-empty pile, we want the computer to decide how many rocks it's going to remove. Well, the options for the number of rocks, you can have 1 rock up to the size of the pile. Let me just choose a random number between those two values. Rand piles computer pile. Okay, so what is this doing? It's choosing a random number between 1 and the total height of the pile. All right, so again, this is the pile the computer chose. This means like the second pile, the third pile, whatever. Once the computer has chosen that pile, piles bracket that means the number of rocks in that pile. So when you write this line of code here, what you're saying is, I want this number to be a number between 1 and the number of rocks in the pile that I've chosen. And that's what you want the computer to do, right? You want it to choose a number between 1, because it can choose one, it can remove 1 rock if it wants to, all the way up to all of the rocks in the pile if the computer chooses that at random, right? Those are the options for the computer. Okay, so the computer has chosen its pile at random, and we made sure it wasn't empty. The computer has chosen the number of rocks to remove at random, but now we just have to do the same thing we did with you on your turn. We took the number of rocks that you took away from the given pile, and we updated our stone counter. We just now have to do the same thing for the computer. So piles, at the pile the computer chose, we have to update that number and take out what the computer decided to take out. Oops, and semicolon that. And we also need to decrease the total number of stones on the board by the number that the computer chose. Okay, so again, this just mirrors what you did in your turn, except everything the computer did was done at random. But again, once he's made his choice of pile and the number of rocks to take away from that pile, you have to update the pile size to reflect that stuff got taken away. And you have to update the running total of rocks to reflect what was taken away. Okay, so now let's just tell the user what happened. After the computer's turn, here's the board now. And let's just print to the screen the game board. Okay, so now at this point, we've displayed the game board to the screen, and now we essentially just play again, right? Now it's your turn. The computer took a turn, now it's your turn. The only thing is, if after the computer's turn, there are no stones left, what does that mean? That means that you lost. So we want to tell the user that before we let the user take another turn, right? Okay, so hopefully this is all done properly. I mean, I kind of know what I'm doing, so I can usually get a program to work the first time through, but a lot of times you just don't know until you run it, right? So I think that I've done this correctly, but let's just see. Let's run this and see if I've made any glaring errors. Okay, so let's bring the output window up. How many piles are there? Let's say there are 3 piles. How many rocks are on the first pile? Let's say 4, and then maybe 5, and then maybe 3. So it says, okay, here's the starting configuration. Choose a pile. Maybe I want to choose that pile of height 5. So since we're starting our position count at 0, I have to say pile 1. How many do I want to remove? Maybe I'll remove 3 of them. So okay, so I removed 3 right here, right? Now it says, okay, here's the game board now. Notice that 453 became 423, right? So it did what we thought it should do. It removed 3 rocks from that pile. And then it tells me after the computer's turn, here's the board now. Okay, I didn't give the program a way to pause before the computer took his turn. So you could also think about a way of doing that, but I didn't put that there. So now it says after the computer's turn, here's the board now. So what must have happened was the computer chose this pile at random and then chose to remove 1 rock at random. So now let's keep going and see if it keeps working. So far it seems to be okay. I'm going to choose pile 0, which is actually the first pile. I'm going to take 3 rocks away from that. Okay, so I took 3 rocks away, and now it says, okay, here's the game board now. Notice 413 became 113. The computer took a turn. He actually made the same move as last time. He chose this pile and removed 1 rock. Now what I'm going to do is choose pile 2 and remove 2 of those rocks. Okay, so when I took 2 away from pile 2, or the third pile, you know, it's sort of confusing to keep going back and forth, but I took 2 rocks away from this 3, and what's left is 1. And so the computer randomly chose the first pile and took the 1 away from there, and now what's left is this. And notice now I got the computer right where I want him. I can swoop in here and win because I choose that last pile. I'm going to take away that 1 rock. Okay, here's the game board now. 0, 0, 0. Everything is gone. I won because I took the last rock. Okay, so it actually kind of appears that this worked. Which is actually kind of a miracle because normally I don't get it to work on the first time. And so of course you should not be discouraged if you don't get it to work the first time. I have more experience than you, but I make mistakes all of the time. This is incredibly lucky that it seems to work the way I wanted it to. Okay, but if you find some errors, let me know. I will put this code on Moodle so you can play with it yourself. There are all sorts of tweaks you could think about doing with this. The most obvious tweak is making it into an actual 2-human game, right? So letting user 2 be a human rather than a computer, and then you could play this against somebody, right? That's sort of more fun than playing against a stupid computer who's doing everything at random. You could also think about, well, is there a way to make the computer play more intelligently, right? There actually is a way to teach the computer how to play really well. It's not easy to see, but you might think about it. You know, there are all sorts of things you can do with this bare code and make it better. You could have more checks in here, right, that I didn't include. There are all sorts of things you can do. But hopefully this program illustrated the usefulness of vectors and loops with ifs. The very last thing I'll say is vectors take getting used to, right? They take quite a bit of getting used to. So, for example, I am comfortable writing lines like this. I'm comfortable with the notation and what everything means. But, you know, if you haven't worked with these before, it can be really confusing to think about, oh, okay, this right here means the particular like place inside the list where I am. That's what this number means. And then this means, oh, the actual entry at that place. Right? So it can become really muddled if you're not used to using these, what everything means as you move through this, right? So like right here, I was able to write this line without much thought because I'm used to these things. But again, it can become muddied. Okay, so this means, okay, what does this mean again? Oh yeah, this means like where I am inside the list. And now when I do piles bracket that tells me the entry at that position inside the list, right? So this right here is a position in the list. This right here is the value of the entry at that position. All of these things take getting used to, right? So if you don't immediately pick up on this sort of thing, that is perfectly fine, okay? Like everything in this course, like loops, like ifs, like whatever, you just have to be willing to do this multiple times until you become comfortable with it. Okay.